Hey folks, Mr. Bullock here, and this calculus lesson is a quickie, you guys. There's two theorems, Rolles Theorem and then the Mean Value Theorem. Let's go ahead and get started with this. Here's Rolles Theorem. Rolles Theorem guarantees the existence of at least one extrema inside a closed interval. All right, and here's how it goes. So for f being continuous on the closed interval AB and differentiable on the open interval AB, if as long as f of a equals f of b, then there's at least one c value in the interval that f prime of c equals 0. Okay, remember this is derivative. F prime of c means derivative, and if it equals 0, that just means we have a horizontal line right there. Okay, so the derivative there's at least one spot on there where it's equal to 0. That's just the same thing. So here's some examples using picks right here. Okay, so here's f of a, here's f of b. See how they're the same height, so they're equal to each other. And right here there's a tangent right there that gets me a horizontal tangent. So here's one that has one horizontal tangent. I call it a flat right there. Horizontal tangent is a flat. Okay, here's one that has infinitely many flats, okay, and it's continuous. So notice this is continuous and it's differentiable, okay. So here's f of a that equals f of b, and so there's infinitely many flats on that closed interval right there. Okay, this one is not differentiable right here. You can't take the derivative at a Sharpie, so that this one is not guaranteeing that there's a flat on there, okay? And it doesn't have to be one flat or infinitely many flats. It could be more than one flat. Here's one that has three flats, one right there, and then one right there, okay? Just notice that f of a equals f of b in all of these, okay? So f of a and f of b, those are your y values, those are the heights. Okay, but if f of a doesn't equal f of b, then it doesn't guarantee that you're going to have a flat. There's an example right there. There are no horizontal tangents right there. Okay, right here, there's no horizontal tangents. See how f of a doesn't equal f of b? They're different heights, okay? Um, it could have a tangent. Here's one that has two tangents right there and right there, horizontal tangents. Okay, it can, it just doesn't guarantee it. So if f of a equals f of b and it's differentiable on the interval, then there's a guarantee that there's at least one flat. Okay, so let's go ahead and use Rolle's theorem to find all c values where the f prime of c equals 0. If f of x is this function right here on the interval -2, 2. Okay, it should be the closed interval I have open. So on the closed interval, -2, 2. Okay, let's find f of a to f of b, and f of b. Make sure that they're equal to each other. Okay, so I'm going to plug in. Here's a, here's b right there. So I'm going to plug in -2 right there, and then I'm going to plug in +2. And remember, when you do it to an even power, you get the same thing. -2 squared is equal to +2 squared. So -2 to the fourth is equal to +2 to the fourth. So in both cases we get 8. So they're equal to each other. So that's good. All right, and this is differentiable right there. So that's good right there. So now we're going to go ahead and find the derivative. Okay, so the derivative is going to be here's the derivative right here, 4x cubed. This 4 comes down and decrease the exponent, and this 2 comes down, multiplied, gets 4, and decrease the exponent, and then set it equal to 0, and factor. Okay, so I get x equals 0, and x equals plus or minus 1 right there. All right, so those are my c values right there. So my c could be 0 or plus or minus 1. Okay, so those are all my c values where I get flats right there at x equals 0 and x equals plus or minus 1. All right, the mean value theorem is just as easy, I think, you guys. So for f to be continuous on the closed interval and differentiable on the open interval, just like the last one, there exists a c value in the open interval such that the f prime of c equals f of b minus f of a over b minus a. Does this ring a bell somewhere, you guys? Do you remember y sub 2 minus y sub 1 over x sub 2 minus x sub 1? This is just slope formula, and that's what derivative is. It's just slope formula. All right, so determine if the mean value theorem applies. Okay, so is it continuous on the interval, and is it differentiable on the interval? And if so, then we're going to find the c value that satisfies this condition right here. Okay, that's what the mean value theorem says. Okay, so determine if the mean value theorem applies, and if so, find the c value in 1,4 that satisfies the mean value theorem. Okay, here we go. So first look at the domain, you guys. The domain at x can't be 0 because I can't get 0 in the denominator right there. But since 0 is not in this closed interval, then I'm okay. All right, so I can go ahead and continue, you guys. If it wasn't okay, say I went from 0, the closed interval 0, or -1 to 4, I'd be done, you guys. I'd say the mean value theorem does not apply in this case. But this case it does, because 0 is not in that closed interval. Okay? All right, so here we go. So now we're going to find the derivative of that function right there, and I'm going to find f of 4 and f of 1, okay? So I'm going to treat this as 5 minus 4x to the -1 power. That's easier to take the derivative, and so when I take the derivative, it becomes, the negative comes down in front and it decreases, so it becomes negative 4x to the -2 power, which is 4 over x to the +2. Here's f of 4. Okay, I get 4, and f of 1, I also get 4. I'm sorry, I get 1. I'm sorry, my bad. All right, and then, so I'll go ahead and do f of b minus f of a over b minus a, and I get 3 over 3, which is 1. So I set the derivative equal to 1, cross multiply, x squared equals 4, so x equals plus or minus 2. All right, but we just want the plus 2 because that's the only one that's in the interval, the closed interval 1, 4. Okay, so if you're in my calculus class, I would assign that as your homework. Take care, everybody.